Closed doors, I'm a fool for your love.
Okay, welcome to my video, everybody. In this video, I prepared some questions about calculations of empirical formula of a compound and the molecular formula of a compound. There will be 4 questions. I prepared the solutions before this video. Now I'm gonna explain step by step what's happening in the solution parts of these questions. In question 1, it says find the empirical formula of a compound. The unknown is empirical formula. Let's say something about the empirical formula. Empirical formula is the simplest formula of a compound. We can only understand which atoms or elements exist and what is the ratio between their numbers. For this reason, empirical formula is called as the fake formula or the simplest formula. I'm going to find the empirical formula. There are some givens about this empirical formula or empirical formula of this compound. Let's read the question completely. Find the empirical formula of a compound that contains 53.70% iron and 46.30% sulfur. Such kind of these questions must be solved by assuming that we have 100 grams sample of the compound. Then we can easily change percentage composition into mass composition. As you see in my question, I changed percentage composition of iron into mass composition, and percentage composition of sulfur changed into mass composition of sulfur. If we have 100 grams of sample of a compound, 53.70% of this compound is iron. This means 53.70 grams of iron we have in 100 grams of compound, and 46.30 grams of sulfur we have in 100 grams of sample of compound. Okay, then in the second step, this is the first step, we assume that we have 100 grams sample of compound, then we change percentage composition into mass composition. Second step, we convert mass composition of each element to their moles. 53.70 grams of iron times 1 mole of iron over 55.85 grams of iron this calculation gives us 0.9615 mole. Why there are 4 numbers after 0? Because in the question I have in the given I have 1, 2, 3, 4 significant figures. So my result must contain 4 significant figures. For this reason, there are 4 numbers after 0 point. And in this step, I convert mass of sulfur into mole of sulfur. 46.30 grams of sulfur times 1 mole of sulfur or 32.07 grams of sulfur. Gram of sulfur can be cancelled. Then 46.30 times 1 over 32.07 makes 1.444 mole. Then in the third step, since the firstly given element is iron, my empirical formula must start with iron and end with a sulfur. I use the same order according to the question. Which element is given in the question? Firstly iron, secondly sulfur. So my formula of my compound must start with iron and with sulfur. Then I found the mole numbers of each element. As you see in this part, I use them as subscripts. Iron, its subscript becomes 0.9615. The subscript of sulfur becomes 1.444. The smallest one is this one. I will divide each subscript by the smallest one. Then I will get the results. Fe1 is 1.502. 1.502. It's neither close to 2 nor 3. For this reason, I must expand the subscripts multiplying by 2. Then I will get the empirical formula as you see here. Fe2 is 3.004. Never a subscript can be a decimal number. For this reason, after running, I get my empirical formula, which is Fe2 is 3. Okay, question 2. sometimes mass composition of elements exist in a formula in the compound will be given directly, as you see in question 2. But sometimes percentage compositions of elements in the formula will be given. First of all, we assume we have 100 grams of compound, then we convert percentage composition into mass composition. But in question 2, directly we can get masses of elements. Let's read the question. Analysis of a compound indicates that it contains 1.04 grams potassium, 0.70 grams chromium, and 0.86 grams oxygen. Question says, find its empirical formula. I start to solution with the conversion between mass and mole. I will convert all the masses of elements into their moles, as you see in this part. 1.04 grams of potassium times 1 mole of potassium over 39.10 grams of potassium makes 0.027 mole. So as you see here, the order is important. The order of elements given in the question is important. They are given respectively. So for this reason, my formula, my empirical formula, must start with potassium, continues with chromium, ends with oxygen. This order is very important. This order is really so important. Okay, after finding the moles or after converting the masses of each element into their moles, I use their moles as their subscripts, as you see. Then I will choose the smallest subscript. Which one is the small subscript? 0.014. It's the subscript of chromium. I will divide each subscript by the smallest one, and then we will get some numbers. K 1.9. This is the result of division. Division of 0.027 by 0.014. K 1.9, CR1 of 3.9. We can easily run these numbers. 1.9 makes 2, K2, CR1 is not shown in the subscript, O4. This is K2 CR04 is our empirical formula. In question 3 and 4, we will find the molecular formula of the compounds. For this reason, we need to know two mathematical expressions to find the molecular formula of a compound. The first one is N times empirical formula mass is equal to molecular formula mass. And the continuum of this formula, this mathematical expression, is the N times empirical formula is equal to molecular formula. I shortly wrote EFM, MFM. EFM refers to empirical formula mass, and MFM refers to molecular formula mass. EFM is the short writing of empirical formula. MF is the short writing of molecular formula. Here you will say, what is the meaning of N? N is the ratio between molecular formula mass of a compound and its empirical formula mass. One more note, molar mass of any compound is numerically equal to the molecular formula mass of that compound. For this reason, in this question, as you see, formula mass is directly given. So in the second question, I will use this note. Molar mass of a compound is 92 grams per mole. This is the molar mass of a compound. But I told you this number is numerically equal to the molecular formula mass of the compound, but the unit will be AMU. So molecular formula mass of this compound will be 92 AMU. But in this question, as you see, formula mass is directly given in AMU. It is 108.0 AMU. It is the molecular formula mass of the compound. I have the molecular formula mass of the compound, 108.0 AMU. I need to find N here, because I'm going to use it in the second mathematical expression. So I need to find empirical formula mass of this compound. To find the empirical formula mass of this compound, you need to find the empirical formula of the compound. You can find it by reading the question carefully. If 4.04 grams of nitrogen combine with 11.46 grams of oxygen to produce a compound with a formula mass of 108.0 AMU, it's the atomic mass unit. What is the molecular formula of this compound? Look, mass composition of the elements are given in the question. I'm going to convert them into their moles, as you see in this part. Then I will use their moles as their subscripts. Then I will choose the smallest subscript to simplify the subscripts. So 0.288 over 0.288 will give us the subscript of nitrogen. It's 1. 0.7163, it's the mole of oxygen. I got it here and I used it as a subscript of oxygen. Then I divided it by 0.288, which is the subscript of nitrogen. It is smaller than this number. Then it gives us this calculation. This division gives us 2.49. It is very hard to run this number. For this reason, we expand subscript of nitrogen and subscript of oxygen by 2. At the end, we get N2, 1 times 2 makes 2, or 4.98. 2.49 times 2 makes 4.98. And this number, as you see, it's very close to 5. I can directly write the empirical formula of this compound is N2O5. Okay. By using the empirical formula, I'm going to calculate empirical formula mass of this compound. In N2O5, in my empirical formula, I have 5 oxygen atoms and 2 nitrogen atoms. I'm going to find the empirical formula mass of this compound. What is the empirical formula mass of this compound? As a definition, formula mass, as you remember, it's the mass of a single molecule of a compound, and its unit is in AMU. Here, I'm going to find mass of a single molecule of dinitrogen pentoxide here, N2O5. Then I'm going to find 5 oxygen atoms times 6.00 AMU over 1 oxygen atom. Oxygen atom can be simplified. 5 times 16.00 makes 80.00 AMU. 2 nitrogen atoms times 14.01 AMU over 1 nitrogen atom. Nitrogen atoms can be simplified. 2 times 14.01 AMU makes 28.02 AMU. You're going to sum these masses, average, they are the masses of each atom given in the formula. You're going to sum them to get this result, 180.02 AMU. This is the empirical formula mass of our empirical formula. And then I have empirical formula mass, and I have formula mass of the compound, formula mass which refers to molecular formula mass. I can easily find N. N is a whole number that shows us the ratio between molecular formula mass of the compound and empirical formula mass of this compound. N times EFM, empirical formula mass, is equal to molecular formula mass, and times 108.02 AMU is equal to 108.0 AMU. You divide both sides by 180.02 AMU, then you get this result, N is equal to 1. In the second formula, now we're gonna find the molecular formula of our compound. N times empirical formula is equal to molecular formula, and we found it is 1. Empirical formula, we calculated it is N2O5. 1 times 2, subscript of nitrogen, N2. 1 times subscript of oxygen, 5. 1 times 5 makes 5. N2O5 is our own molecular formula. As you see here, empirical formula of our compound is the same as its molecular formula. Now we go on with question 4. Okay, let's go on with the solution of question 4. These solutions look really so complicated, but if you are able to follow the steps carefully, you can understand everything clearly. In question 4, I have 1 given in the first sentence, 92 grams per mole. This is the molar mass of my compound, but I told you in the solution of third question, molar mass of a compound is numerically equal to the molecular formula mass of that compound. For this reason, I can say molecular formula mass of this compound is 92 AMU, atomic mass unit. Analysis of a sample of the compound indicates that it contains 0.606 grams of nitrogen and 1.390 grams of oxygen. Find its molecular formula. I have mass composition. I can change them into mole. After changing them into mole, I can write these moles as subscripts of the elements. After simplifying the subscripts by using the smallest subscript, I can get the empirical formula of this compound. I have MFM, molecular formula mass, here it is. And then after finding the empirical formula of this compound, I can find the empirical formula mass of this compound. I have MFM. You found EFM here. Then take the ratio of MFM to EFM to get the N. And N is going to be 2. After finding N, you have here empirical formula. Multiply the empirical formula by 2. 2 times NO2, 2 times subscript of nitrogen 1, 2 times 1, 2 N2, 2 times 2, 2 is the subscript of oxygen, 2 times 2, 4, so N2O5 is the molecular formula of this compound. Okay, again, slowly. Let's examine the question carefully. What is given in the question and what is unknown in the question? The molar mass of a compound is 92 grams per mole. Okay, in the first sentence, I have 1 given. This is the molar mass of a compound. And in my notes, I have that molar mass of a compound is numerically equal to the molecular formula mass of my compound. So I have MFM, molecular formula mass. As you know, to find the molecular formula, we have 2 mathematical expressions. One is this one, and second is this one. Okay, let's go on reading this question. Analysis of a sample of the compound indicates that it contains this mass of nitrogen and this mass of oxygen. Okay, look, I have the mass compositions of this compound. I can easily convert them into mole, as you see. After converting them into mole, I will use their moles, most of elements, as their subscripts, as you see. Then I will choose the smallest one and divide both subscripts by the smallest one. And after dividing the subscripts, you will get N1 or 2.01. 2.01 can be easily rounded to 2. So my empirical formula came out. It is empirical. It is NO2. This is my empirical formula. Put it in your pocket. Okay. It's waiting for us. Now, by using empirical formula in this part of solution, I'm going to find the empirical formula of my compound. The empirical formula is NO2. In this formula, I have 2 oxygen atoms, 1 nitrogen atom. Then, by using their average atomic masses, find the empirical formula of this compound. Okay, I got it. It is 46.01 AMU. Okay, in the question, you have molecular formula mass. It is 92 AMU. And you calculate the empirical formula mass, it is 46.01 AMU. Divide both sides by 46.01 AMU to get the numerical value of N. N is going to be 2. Okay. In the second part of this solution, I have the second mathematical expression. N times empirical formula is equal to molecular formula. We got N, it is 2, and as I told you, we got empirical formula here, NO2, multiply 2 by subscript of nitrogen, 2 times 1, 2. Yes, there is no number here, but 1 is not written as a subscript. It's not shown, okay? 2 times 2, 2 is this 2 is the subscript of oxygen. 2 times 2, 4, so it is N2O4. This is our molecular formula. What is the meaning of molecular formula? Molecular formula is the original, correct formula for a compound. Okay, thank you for watching.